Dear children, today we are going to have a discussion on a theorem, and its name is Thales theorem. This Thales theorem is also called as basic proportionality theorem, or in short we call it as BPT. So when a theorem starts, it starts with a statement, and let us first start with what does that statement of a theorem says. It states that if a straight line is drawn parallel to a side of a triangle, what does it mean? He says that if there is a triangle and if you have drawn a line parallel to a side of a triangle, means if you have drawn a line parallel to any side, a side means one side, a side toward in this way, parallel if you have drawn, then it divides. What divides? This line divides. I'm going to change that color. That is, it's going to divide this line is going to divide other two sides. Which are the other two sides? This and this. He says that this line is dividing the other two sides proportionally means what? Suppose I'm going to consider this upper part as A, this has B, this has C, and this has a D measure. So what he says that is A by B is equal to C by D. Let us see once again what he states, that if there is a triangle in this way, if we have drawn a line parallel to one side of a triangle, then he says that that line, which line? This particular line will divide other two sides proportionally. Proportionally means what? Suppose the measure of this part is A, measure of this part is B, and measure of this part is C, and the measure of this part is D. What he says that A by B, the ratio what you get by doing the simplification A by B will be equal to the C by D. That's what he states in the Thales theorem. So here we have come to know that what I need to prove. I need to prove this thing, and what he has given, he has been given that there is a triangle and one line is drawn to one side of a triangle. I need to prove that this one line is been dividing the other two sides proportionally. Let us start the theorem now. So it starts with the given data. What he has given? He has given there is a triangle in ABC. Where is the triangle? Here we are seeing this is a triangle ABC. This triangle, where this triangle ABC is a triangle, what he has considered, what he has done thereafter, D is parallel to BC. Where is D? See there. This is D, right? This D is been already parallel to the BC. So our original triangle, where it start the theorem, is up to here. There is a triangle ABC in this way, and there is a line DE which is parallel to BC. This is our diagram according to the given data. Then the next step is to prove. What I need to prove? I need to prove that is what he states, that it divides the other two sides proportionally. Proportionally means what? Proportionally means the ratios are equal. Which ratios are equal? This part divided by this part divided by this part, that ratios are equal. That what I need to prove in the proofs to prove section. What is that? He has written here, that is AD by BD is equal to AE by EC. That is what I need to prove. So next is construction. What we have taken the construction here, that is join DC and BE. Here we have mentioned that joining the DC and BE, after joining this, what he has mentioned, that draw EL perpendicular to AB. Where is EL? Here the orange color mark what we are observing is nothing but the construction part. This EL we have drawn perpendicular to this line AB, that is AB. This line has been drawn perpendicular. Then what we have did, we have considered DN. Where is DN? DN is here. DN is perpendicular to AC. This line we have drawn perpendicular. This is comes under the construction. I repeat once again that what we have did in the construction, that here we have joined BE, DC, and we have drawn DN perpendicular to AE and EL perpendicular to AD or AB. These are the parts which comes under the construction. The next part of a theorem is proof, in which we will have two parts, that is a statement and reason. See what we have written in the first step. Before going to the proof of a theorem, have an idea about that on what basis I can prove, or how can I remember this theorem. See, we have to prove that what AD by BD is equal to AE by C. In order to prove AD by AD is equal to BE by BC, this theorem is going to be proved on the basis of the principle, that is area of a triangle. So what we are knowing, that area of a triangle is nothing but half base into height. Okay, we have come to know that which principle we are going to use to prove in this theorem, that is what area of a triangle. In order to have a area of a triangle, we should know the what is the formula and which triangle I have to use. So since I need the relation between an AD and BD, what I am going to do is I am going to consider what triangles I am going to consider, that is ADEC. In the first numerator, here in the numerator I have considered ADE, and in the denominator I have been considered BDE. Where is BDE? BDE is here. That is, I may call it as the top triangle and the left bottom triangle. This is what we have taken. So I am repeating once again, which triangles we have taken. We have taken the top triangle, that is what ADE, this one triangle, and the bottom left triangle, which is that BDE. This part we have considered in this part, where in the statement, which triangle I have taken, the upper triangle and the left bottom triangle. So for these triangles I have applied the area of a triangle. Now see that here in the numerator I have considered ADE. ADE is here. So I have considered here AD as a, I have to apply the area for triangle, right? So here base becomes AD, height is EL. What we have written here, that area of triangle ADE is equal to half of AD into EL. This is what we have written in the numerator. In the denominator, what we have taken in the denominator, triangle BDE. BDE. Where is BDE? It is here. This triangle. What is the base of this triangle? That is, half is common, for half is a formula, and half BD. This is the base of this triangle. So what is the height? Height is also EL. Why it is outside the triangle? Why? Because ABDE is a, what we can say, that is a scalene triangle. That is what obtuse angle triangle. What is obtuse angle triangle? That is, one angle is more than 90 degree. Here angle triangle BDE, I'm going to write separately. BD is here. And why the altitude is outside that triangle? Why? Because this is a, what kind of a triangle? Obtuse angle triangle. Obtuse angle triangle means this angle, what I'm showing. I'm going to change the color of that thing. See, this angle is more than 90. If such a triangle is there, the altitude will be outside the triangle. That is, if you join a line, extend a line of the base, and if you get the height, the shortest distance from the vertex to the base, that will become the height of that triangle. So now for that sake, here what we are saying, that again for this triangle, which triangle? That is BDE. For this triangle the height is EL, that what we have written here, that is half of DB into EL. Now here in this, half get cancelled, EL get cancelled. After that you get, that is area of triangle ADE by BD is equal to AD by BD. After the cancellation we are left with AD by BD. I am going to call it as equation number 1. After that we are going to consider those two triangles apart from those triangles we have taken now, but one triangle is common in both the cases, and that is upper triangle, which is that here in the second equation we have taken, in the second comparison we have taken the top triangle and the right bottom triangle. I am repeating, that is top triangle and the right bottom triangle. What is the right triangle? A D E. See, observe that in the previous equations also we have taken AD in the numerator, in the this also we have taken numerator ADE, but in the denominator once I have taken the left bottom triangle, once I have taken the right bottom triangle. So this is what DCE. Now we have applied the area of a triangle. Here once you apply the area of a triangle, for which triangle? That is upper triangle ADE. This triangle, the base I am going to take AE. What is the height? Height is this thing. Why? Because we have taken a perpendicular line. So DN, the base is AE, height is DN. So here we have written in the numerator. In the denominator we have taken, that is a triangle DEC, this triangle. So again the same thing, the base will be C and the height will be DN. Already I have told you that in case of which case, that is obtuse angle triangle, that is DEC, the height is outside the triangle. So what we have written, that is area of triangle CDE is equal to half of EC into DN. What is EC? Base. What is DN? Height. So when you compare those equation, here half of get cancelled and DN get cancelled. So what you are left with? You are left with triangle, area of triangle ADE divided by area of triangle CDE is equal to AE by CE or EC. So this is, I am going to call it as equation number 2. Now when you observe equation number 1 and 2, you can see that almost what I needed is there on the right hand side. What is that? AD by BD is equal to AE by C. That is already almost we are at the end of a theorem. But when you observe the left hand side of the both equation, observe the left hand side of the both equation, you can observe that in the numerator there is both the cases, in the both the equations the numerator is same, ADE ADE. When you observe the denominator, which are the denominators here is BDE, in the second equation it is CDE. See, here I can't directly apply the axiom one. Why? Because in the left hand side the denominators triangles are different. So if I show that those two triangles area are equal, then I can apply the axiom 1. So here we have learnt in the 9th standard one of the theorem that, and what is that theorem? If suppose there are two parallel lines are there, just I am writing once again, suppose if you consider two parallel lines are there. So if any triangles are standing on this, suppose if it is triangle, one triangle is in this way, it is standing in between what, two parallel lines, and one more triangle if you have drawn from the same base. See what I'm using the words, there is a two parallel lines are there and a triangle I have drawn. If there is a triangle which is standing on the same base means what? This is the same base, right? The both the triangles are standing on the same base. One triangle is this side, another triangle is this side. So that theorem states that if a triangle is being standing between the same parallel lines, if it is two triangles are standing on the same base and between the same parallel lines, see what we have drawn. Suppose if it is A, B, C and D is here. So what you can see that there is a two triangles which are standing on the same base, what? B, C, between the two parallel lines. Suppose if it is XY, it is X, Y, P and Q. So XY is parallel to PQ. Therefore, these two triangles are standing on the same base. What is the same base? Common base BC. And they are between the same parallel lines XY and PQ. In such case, if the triangles are standing on the same base and between the same parallel lines, then those two triangles area are equal. That is BAC is equal to BDC. Here both the triangles are having a equal area. Which triangles have a equal area? That is BAC and BDC. These two triangles are having a equal area according to the theorem which you have learnt in the 9th standard. So that property I have used here and I have written What I have written that the denominators what we have used in equation number 1 and 2, that is the left triangle bottom triangle and the right bottom triangle. See, we have used one word. What we have taken, I am just going to draw separately so that you can understand clearly. So this is the bottom part of the given diagram. This is D, this is E, and this is B, and this is C. So what he has given that DE is parallel to BC. He has mentioned in the given part. What? D is parallel to BC. This is parallel to BC. Then what we have done? After that we have joined BE and DC. Can you observe that this is parallel to this line and D is a common base? Try to understand, D is a common base and there are two triangles. Which two triangles? That is BDE is one triangle, DEC is one triangle. These are the two triangles which are standing on the same base and between the same parallels, so they must have a equal area. So what I have written here is that these two triangles, which two triangles? BDE and CDE, these two triangles have a equal area. Why they have equal area? Because the triangle standing on the same base and between the same parallels have a equal area. So based on the theorem which we have learnt in the 9th standard, we have proved that the denominator is also same. When you observe clearly from the 1, 2 and 3, see what I have considered equation 1, 2 and 3. What we have did, we have seen that the numerator of the first equation and the numerator of the second equations are same. No doubt they are common, means they has to be same. So when you observe the denominators, again we have proved that those two triangles are equal in area. Where I have proved? Here in the third equation. What I have proved? That this part, what is that? BDE is equal to CDE. Now what it becomes? That both the numerator and denominators of the both the equation and 1 2 are same. So on the basis of equation 1 2 and 3, what I can write? That is AD by BD is equal to AE by C. Why I can write? Why? Because here ADE is equal to ADE. Both the numerator of equation 1 and 2 are same, whereas the denominator also same. Why they are same? Why? Because already I have proved. What I have proved? That is BDE is equal to CDE. Therefore, according to equation 1, 2 and 3, what I can write? That is AD by BD. What I have mentioned here, AD by BD is equal to AE by CE. That is according to the theorem what I needed to prove, I have proved by axiom 1. So this is a theorem and this has been asked many times in the question paper for 4 to 5 marks. If it is 5 marks, it will start from the statement state and prove BPT, or else he can ask state and prove Thales theorem, or else he can ask that state and prove basic proportionality theorem.